Alright, so here is the Stata video that I promised you guys. This is sort of what Stata looks like when you open it up. This is the results box. Everything that you sort of enter into Stata, you'll sort of see pop up on this screen here. Down here we have the command box, and this is where we tell Stata what we want Stata to do. And this is primarily where you'll be interacting with Stata, either here or with a do file. And a do file sort of is a pre-made entries for your command box here. And like I told, I think some of the classes, a do file allows you to sort of run everything at once and do things more quickly, but it also lets you save specific subsets of commands that you might want to keep for later and reuse in a different context. It lets you save them, and that way you don't have to recode them every time. You can just go copy and paste and change the variables that you need to change, and you have exactly what you need ready. But before we can really do anything, we have to look for a data set. And a data set is going to be a file that contains a bunch of data, right? That has a bunch of variables in it, and then we're going to try to run different analyses on the variables in the data sets. So in order to do that, we have to go download one. So I'm sort of assuming, okay, you've gone and downloaded one, and now you have to locate it on your hard drive. So I've already done that. I know where mine is. So what I do is type in CD, and that stands for change directory. If you can see down here, this is my working directory. It's e://new_PC/boxsync. So what I want to do is I want to go look, where's my data set exist? Where does it exist on my computer? And that's where I want to point Stata towards. So I type CD, and in this case, my data set is actually where it is. So I'm just going to go ahead and do this again just for an example. Shared. And what's important here is definitely when you do this, you're going to need your colons. I hit enter, and what that does is it points Stata to the directory that I need it to be in. I'm working on a Windows machine, so what I did is I went in and just copied the file path and pasted it into Stata, and that works fine. So if you're using a Mac, all you have to do is do your sort of two-finger click and hit get info, and under the information window that pops up, it will show you the file path, and you can either select that and copy it, or you can sort of type it in. So if you guys have questions with this, sort of let me know. After you play with it a few times, you sort of understand. It becomes really clear what I'm talking about. So if you have issues, let me know. So what I've done, I've changed Stata, and Stata knows where to look when I want to tell it, all right, I have this data set, use the data set, right? And so that's what I'm going to do. I'm going to say use, and my data set in this case is NES. It's an NES data file from the 2008 presidential election. And again, parentheses are very important. So what I do is I hit enter, and you'll see immediately up here it populates the variables. It populates a bunch of variables up here. This is great. Now we can actually start playing around with the data. So the book uses the list command sort of to illustrate a bunch of different things that you can do with Stata. And so I'm going to do that now, but I'm also going to sort of show you something else that I think is a little more useful. So what we can do is, like, let's say we want to list age, right? So this is age of respondent. I'll sort of pull out these things so you can see them a little better. Age of respondent. So let's click list age. Okay, so we have this person is 19, this person is 51, this person is 27, etc., right? and we're going down. So each one of these sort of entries is connected to a single individual that took the NES election survey in 2008. So we can click more, and what we quickly find out actually is that this just keeps going. So I can hold this down for a while, it's going to keep going, or I can hold down enter or escape, it will go to the end. And we see that here our data file has 2,323 people that responded with their age. So that's a lot. So what we can do instead is something that makes it a little easier to sort of see, because if we're looking at each individual person, we don't really get an idea for the wider trend in our data set. So what I can do is click tab age. And what this does is, okay, I find out that there are 28 18-year-olds in our data set, and they make up 1.23% of the overall respondents. So we can click through this. There are 48 50-year-olds, which is 2.11%, and continuing all the way down to, I believe, 93. We have two 93-year-olds, stuff like that. And even then, that still really doesn't give us an idea of the trends. We see, there's a lot of 1%, 2%, stuff like that. So we can go look for a different variable. And so what they've done here is they have age, which is everyone's individual age. But then they've grouped the ages. So if you've ever taken a survey and you see, 18 to 35 is a common grouper, but even 18 to 25 or something like that. So what they've done here is that's what they've done for us. So we can type tab age 5, and this becomes way more manageable, right? So we can see 18 to 30 is the group that they give us, and we see 490 people responded. That's 21% of the data set. 31 to 40, and so on and so on. So there we go. We can also do this with other things. I think income is something that's relatively similar, something that we're going to have to look at a lot in this class for sure. So we can tab income, and again, this is a variable that combines income ranges. Looks like every couple $1,000, and then it gets a little wider. So this is useful. And this, you can go around, and this is every time you get a new data set, it's useful to go in and sort of use tab and use list to get an idea of what the data looks like. So this is sort of getting used to Stata, getting used to your data set. There's also interesting things. So say you want to isolate, you're just playing around, you want to isolate a couple of things. And so what you can do is use what's called logic commands. And so what that is, if and, or if or something like this. So let's say let's say we want to list the income if a respondent is, let's see, if a respondent is older than age 50, and see what happens. Okay. So we still get everyone, but we don't get everyone, right? Because we get 294, but we don't get 295, and we're sort of missing 297, 298, because these people are presumably under 50 because of the way they responded. And what that does is it limits sort of what we're looking at. So we can continue this and go here and click and pull this up, and I can also use tab with this. So I can hit tab income, and so now we're just looking at people that are above age 50, and hopefully we're trying to find trends here. So what's more interesting is you can play around and see, younger. Okay, yeah, so we want to compare these two. We can see above 50, there are 6.3% of people that make less than $3,000 a year. But as soon as we drop below 50, we get a huge spike in that. We get about 12% of respondents under 50 make less than $3,000. And we can imagine, you can imagine this. A lot of you guys probably don't have consistent incomes and stuff like that, and so you are going to fall into a category like that. And so we can imagine as we sit and play with the data why we might expect to see differences between over 50 and under 50, and we can change this too. We could play around and say we want it to be under 25. We could say over 25, stuff like that, and you can play around with these logic operators as well. So let's do tab income R if age is equal. So what you've seen here is I use less than, and greater than. So if I want to do equals, I don't just do one equal sign, I do two equal signs. And let's say, tab income if our age 19. And what we find out is initially there's not very many respondents, right? But they are generally clustered around the 3,000, 4,000, 5,000 range, which is what we would expect, right? What also we can do is we can say, oh, okay, well, actually, we're not interested in 19-year-olds because, for whatever reason, we just think that they should be excluded from what we're looking at. Maybe they're an anomaly, or they're different, or for whatever reason. We can put this exclamation point, and what this means is not equal to. So this is going to exclude every person who is 19. Maybe this is a little more clear if I use a different example. And so what I have over here actually is what's called a feeling thermometer. So this is how people feel about a certain group of people or a certain person. And let's see if I can find it here. So cath therm. So this is how do people feel about Catholics? I had a misspelling. There you go. Okay, so what we see is lots of people here in the middle sort of don't really have any feelings about Catholics, and definitely more on the positive side, it seems. But we still have people that have put an absolute 0. We have people that put an absolute 100, stuff like that. So maybe we are concerned about these extreme responses, and so maybe we want to cut this out of our data. And so what we can do is type tab. Tab Catholic. Sorry, Catholic therm if Catholic therm is not equal to 100, and Catholic therm is not equal to 0. Okay, and so what I've done here is, so this shows everyone, but it doesn't include those who responded with 100 and those who responded with 0. And that's captured by this if command, and I've doubled it by saying and. So if Catholic thermometer doesn't equal 100, I want it. And if Catholic thermometer doesn't equal 0, I also want to see it. Okay, and so if you guys have any questions about sort of what logic operators we can use or what other mathematical operators we can use, all of that's on page 12 and 13 of the Stata book. And I guess just one last thing is this idea of debugging. So I want to tab out age and income, right? So this is something that you can do. You don't just have to confine your tabs to just tab age, but I can do tab age 5 by income R. And what I get is this massive breakout table. So it's a little confusing. This is maybe not something I want to do, but you can break stuff out like this. But you'll notice that I've separated these just with a space. But if I hit a comma, nothing happens. Because what we see is a comma indicates there's an option. And an option is related to whatever specific command I'm giving it. But yeah, so you make sure that you haven't added a comma where it shouldn't go. But also, so let's go back to an earlier example. So let's say we're doing tab age. So here we just have this, right? But say we want to sort of see everything above a certain threshold. So we do our if command and we type $100,000. Oh, no, let's do tab age if over 50, right? This is what we were doing earlier. But I get this 50 invalid name. So what does that mean? Oh, it's because I have forgotten to type in my second. So if I type in if, I have to then type again another variable name. So I could also do this income R, right? Or probably easier if it's income R if age over 50. And also, everything in Stata is case sensitive. So if I want to do tab age 5, I can't capitalize tab here. So, and likewise, I can't capitalize age 5 because Stata doesn't recognize it. It says I don't have something that's stored like this. But so you have to make sure that you type it in correctly. Okay, so I've run through a lot. Hopefully it was useful to you, and you'll be able to go back and watch the parts that were maybe confusing. And if you do have questions, certainly let me know, and just get back to me, and I will sort of clear things up for you, either in lecture or on Friday, or if you want to come to my office hours. So hope this was useful, and I'm looking forward to hearing your feedback. Hey everyone, this is just sort of a postscript. I'm recording on my laptop, so the audio might sound a little different. Just want to sort of reiterate something going back and watching this video. What I'm sort of showing you are building blocks that you can use to then do other things. Like you can do a lot more complicated things with these mathematical commands or the logic commands or the Boolean commands. And you can use them in different contexts, not just in the context that I've given you now. And also, you could sort of think about what everything I showed you is really preliminary to most of the hard analysis that we're going to be doing. We're not really going to be cutting out any data from our final analysis, right? Because we're trying to analyze the world how we have observed it, right? So we're not trying to change the observations that we've received, but this is just a way for us to sort of get used to get to know the data, try to find trends, and we can do that very easily by sort of limiting the scope that we initially look at it, and that sort of gives us an idea of where we can go in the future.